motion. Periodic motion is something that repeat itself. For example, rotation of Earth. Rotation of Earth is also example of periodic motion. So when Earth rotates, it take complete one round in 24 hours. So we can say this motion is a periodic motion. Means if any object repeat itself after certain time interval, it means that motion is periodic motion. So we can say this pendulum also it's a periodic motion because it repeat itself after certain time interval. So this is the periodic motion. Now second one is oscillatory motion. Any to and fro motion. Again example of the pendulum. Any to and fro motion, just like this pendulum is there. If it is moving to and fro, so this motion is oscillatory motion. It may be periodic also if time period remain constant. Means after certain time period, if repeating itself, it means this motion is also periodic motion. Now one more example of this one is a simple harmonic motion. If you look at this spring, if I pull this object in downward direction, and after that it will oscillate to and fro on a straight line. So to and fro motion where force is directly proportional to minus x means force is opposite to the displacement. If you see this spring here, if you pulling a spring downward, spring force will be upward, but if this block is moving upward, spring force will be downward. It means F is directly proportional to minus x. So if we simplify this one, we can write F is equal to minus kx. So this is the example of simple harmonic motion, or else we can say this is the equation of simple harmonic motion. So in this equation, if I write F is equal to m into a, so that should be equal to minus kx. And again I can write a is equal to minus k by m into x. And dimensionally if I see that k by m is equal to omega square. Omega is what? Angular frequency. So angular frequency of this one is omega. Now omega is equal to, I can write under root k by m. So there is two condition for simple harmonic motion. First one, F is equal to minus kx, and second condition is that a is equal to minus k by m into x. Basically both are same. First one in terms of force and second condition in terms of acceleration. All right. So we compare simple harmonic motion with circular motion as well. For example, compare. It's not like simple harmonic motion is circular motion. We can compare. For example, if object is moving like this one from this point and it's moving over here one, then two, and then like this one. So we can see the projection of this object is falling on this surface. See, projection of one is falling over here. Projection of 2 is falling on y-axis, and similarly when object will reach at this point, projection again will fall on this one, then projection again will fall on this, and projection fall on this one. So actually what is happening, if object is moving in a circle, in that case projection of this object is moving on this straight line. So projection of this object moving on this straight line if object is moving in a circle. It means simple harmonic motion we can also compare with circular motion. Just compare. So if I compare simple harmonic motion with circular motion, right now if you see this diagram, this object is starting from point P and reaching at this point, and similarly it's going like this one. So if object is going like this one, it's moving in a complete circle. In that case, what is happening? Image of this object means projection of this object falling on this. See, when object reach at this point, projection over here. Object reach at this point, projection over here. When object reach this point, projection over here. So we can conclude it, when object is moving in a circle, their image is falling on this y-axis, moving to and fro on a straight line. So we can compare simple harmonic motion with circular motion. So anytime if you have to find out y, if you look at this triangle, if I have to find out y, so y is equal to, I can write r sine. So y is equal to r sine omega t, where r is what? Amplitude, and omega is what? Frequency. If I differentiate this y, what I'll get? V is equal to r omega cos omega t. And cos omega t we can convert. How we can convert cos omega t? In place of this cos omega t, what I can write? Y, this is r, so this one is omega t. So sine omega t y divided by r. If you can see, this will be r square minus omega square. So what will be cos omega t from this formula? Cos omega t, that will be equal to under root r square minus omega square divided by r. So if I put this value over here, so v is equal to, I can write r omega, and cos omega t I can write under root r square minus y square divided by r. After solving, I'll get v is equal to omega under root r square minus y square. So this is again condition for simple harmonic motion in terms of velocity, angular velocity, amplitude, and displacement at any time t. So once again, if I differentiate this equation, means once again if I differentiate this v is equal to r cos omega t, what I'll get, v is equal to minus r omega square sine omega t. And you can simplify this one so that v will become a, and we can simplify after differentiation, v will become a. So a is equal to, I can write minus omega square into r sine omega t. And in place of sine omega t, r sine omega t, I can write y. It means a is equal to minus r square y. So basically, there are four conditions for simple harmonic motion. First one is F is equal to minus kx, that is in terms of force and displacement. Second one, we can write A is equal to minus omega square x. We can also write y as well. Uh, we can also write A is equal to minus omega square y if I take variable. We can also write F is equal to minus ky if I take y as a variable. Then I can write V is equal to omega under root A square minus x square. We can also write v is equal to omega under root a square minus y square, and I can write x is equal to a sine omega t plus phi, and I can also write y is equal to a sine omega t plus phi. So these are the conditions for simple harmonic motion. Once quick recap, this is in terms of force and displacement, this one acceleration and displacement, then velocity and displacement, and then displacement and time. So these are the four equations for simple harmonic motion. Now, to make better understanding of this, I have to prove that this one is simple harmonic motion. So if I have to prove that this one is simple harmonic motion, in that case, either it should satisfy this equation or else it should satisfy this equation, and similarly, otherwise it should satisfy this equation a square minus x square, or else it should satisfy x is equal to a sine omega t plus phi. If this equation is satisfying any one of these four equations, it means this will be the simple harmonic motion. Means if I am able to convert this equation in any one of these four equations, so that motion will be the simple harmonic motion. Now, if I differentiate this equation once, so what I'll get, dy by dt, I am differentiating this equation dy by dt, that is I into a omega e power I omega t. And once again, if I differentiate this equation, second derivative d square y upon dt square, that should be equal to minus omega square a e power I omega t. And we know this one is y. This whole thing is y. We can say this thing is y. This whole thing is y. So we can write a is equal to minus omega square into y. Now this is satisfying one of this equation. Just difference is one is x and second is y. Both are displacement. We can take in any direction. So it is simple harmonic motion. So this is the example of simple harmonic motion. Now we have another question based on this one. Find the amplitude of initial phase of particle in a system. Is motion is given as this one. So this is the motion given for particle. I have to find out amplitude and initial position. So what I can write here, what is the process for this one? In place of a, r, I can write r cos phi. R cos phi is equal to a, and in place of b, I can write r sin phi. So that is equal to B. Now, if I put that equation over here, so and simplify, so y is equal to what I can write r cos phi sine omega t plus r sine phi into cos omega t. And if I simplify this one, I can take r common, what I can write sine omega t into cos phi plus cos omega t into sine phi. And if I simplify this one, this is the equation of sine a plus b. And after simplifying, what I'll get y is equal to r sine omega t plus phi. And how to calculate that r? Just square and add. If you square and add, you'll get r square is equal to a square plus b square. It means r is equal to under root a square plus b square. And how to get phi? Equation number 2 divided by equation number 1, I will get phi. So tan phi is equal to what I can write here, b divided by a. So in this equation, you can see this r will be this one and tan phi will be this. So if I substitute this equation, then I can find out amplitude and tan phi both. So what I got, this is the amplitude of this one and this one is tan phi. Now, there is a one question, why there is a 1 kg mass executing simple harmonic motion, which y is equal to this one equation is given, and what is the amplitude of the displacement? They are asking amplitude. Amplitude का मतलब होता है maximum displacement. So what is the maximum displacement? 0.6. First answer of this question is 0.6. Maximum displacement is 0.6. So that is amplitude. What is angular frequency? Coefficient of t will be angular frequency. Means what I am doing, I am comparing with a sine omega t plus phi. So first thing they ask for amplitude. So what is amplitude? 6. And what is angular frequency? 100. What is phi? What is phase difference? Angular frequency, initial phase. Initial phase means t is equal to 0. If I put t is equal to 0 over here, so I will get initial phase. So if I put t is equal to 0 in this equation, so initial phase is what? 4 pi. So phi is equal to 4 pi. So I got equation for first three. Amplitude, that is 6. Angular frequency, that is 100. Initial phase, phi, that is equal to 4 pi. And velocity, for velocity what I'll do, I need to velocity they are asking. So what is velocity formula over here? So velocity formula is this one. So using this we can find out velocity at any point. Can I find out velocity at any point? V is equal to, what is the formula? Under root a square minus y square, and omega is given. Omega how much? 100 I can write, that is 100. And a is also given, that is 6 minus 6 chi square minus y square, that is velocity. For acceleration, what is formula? Minus omega square into y. So that is equal to minus 100 chi square into y. That will be acceleration. And if I have to find out kinetic energy formula is half mv square, and just I have to substitute value of this one. So from this we can find out all the variables. A particle 0.8 kg executing simple harmonic motion with amplitude 1 meter and periodic time 11 by 1 second. 11 by 7 second. Calculate the velocity kinetic energy of the particle moment when displacement is this one. So first thing what we have to do for this, first I need to find out velocity. So I have this velocity formula. Velocity is equal to omega under root a square minus x square. So if I write v is equal to, this one will be 2 pi by t under root a square, and what's the value of a? A value is 1 chi square and x value is given, that is 0.6, 0.6 ka square. So if I calculate this whole thing, I will get 2 pi, and time period is given. Time period you can write 11.2 seconds. It means 2 pi into 11 by 7, and that will be 1 chi square minus 0.6 chi square. After calculating this whole thing, I will get 3.2 meter per second. Now, how to find out kinetic energy? Kinetic energy formula is what? Half mv square. So half mv square, just I have to substitute value of this one, and mass is also given 1 by 2. Mass is 1, and velocity how much, 3.2 ka square, and if I calculate this one I will get 4.1 joule.